Welcome to the VisualCAM Quick Start tutorial series, brought to you by MecSoft. Today we'll be demonstrating true shape nesting. Before we begin, let's talk a bit about the VisualCAD display. When you run VisualCAD for the very first time, your screen may look like this. These windows on the left belong to plugin modules that are currently loaded. For now, let's close all of them. Now, let's begin by launching the VisualCAM Nest module. From the Plugins pane of VisualCAD's home ribbon bar, you will see the VisualCAM main menu. Drop down the menu and pick Nest to load the nesting module. Docked on the left, you will see the nesting browser. Notice that it is organized into tabs, representing each step in the nesting process. You can resize the width of the browser, making sure that all of the command icons and menus are easily accessible. Now, let's load the part file containing the geometry for nesting. From the VisualCAD main menu, select Open. Locate the VisualCAM Quick Start folder shown here. Then, select the VisualCAD part file named True Shape Nest Quick Start Tutorial, and then pick Open. The following basic steps are included in the nesting process. First, we load the VisualCAM Nest module and define the nesting type to be performed. Then, we open the VisualCAD drawing where the stock material and production parts are staged. Then, we select the sheets to nest our parts in, and then select the parts to nest. We choose our desired nesting parameters. Then, we preview the nest, making any final adjustments. Finally, we commit the nest, creating the actual nested sheet geometry. Let's take a look at what we've done in VisualCAD to prepare for nesting. You can refer to this as the staging process. We have brought together and located on the screen the geometry that we want in the nesting process. As you can see, we have one or more shapes that represent the stock or the remnant material. We also have one or more shapes that represent the production parts that we want to nest within the stock material. Now, from the nesting browser, choose the Select Type of Nesting tab. In this guide, we will be demonstrating true shape nesting, so we will select that option. You will notice a Help button located on each tab of the nesting browser. Selecting it will display documentation for each option on the active tab. From the Select Sheets tab, pick Select Curves. Now, we select the shapes that represent the stock material and then right-click or press Enter to end the selection. Notice that entries are made into the table for Sheet 1 and Sheet 2. For the Count column, let's enter 2 sheets of each of these for the sake of nesting. The Starting Corner and Nesting Direction columns allow you to control where the nesting should begin and in what direction it should proceed. This is good for remnant control. We'll come back to the Grain Direction column in a little bit. Next, we'll select our parts to be nested. Pick the Select Parts tab of the nesting browser and then pick Select Curves. Then we will window select all of our part geometry and then right-click or press Enter to add each part to the parts list of the nesting browser. The nesting software determines the exterior and interior of each selected part. As we can see in the parts list, each exterior closed curve is defined as one part. Any interior closed curves are defined as holes within each part. Now, we'll enter the count for each of the parts that are needed in the nest. For this tutorial, you can use these amounts or adjust them to see different nesting results. Now we'll select the Count column from any part in the parts list and then type in 50 and press Enter. Since we want all parts to have the same count, we right-click on the count we just entered and select Make All the Same, and the counts for each part are updated. I'm going to change the incremental angle to 45 degrees. This means that the nesting software will attempt to rotate any of the parts in 45-degree increments to achieve a better fit. I'm going to enable the Mirroring Parts for Nesting option. I will also enable the Allow Part Inside of Other Parts option. This will allow smaller parts to be nested within the cutouts of larger parts. If you have a part that you do not want rotated or mirrored, you can check the box next to Fixed in the Orientation column of the parts list. The orientation of this part will be maintained in the exact orientation that it is staged throughout the nesting process. Now we'll select the Choose Nesting Parameters tab of the nesting browser to set two additional parameters. The first one sets the distance between adjacent parts. We'll enter 0.15 here. The second is the distance between the outermost parts and the outer edge of the stock material. We'll set this to 0.25. There are also options to automatically tag each nested part, and layout options for arranging your nested sheets. Now we'll select the Estimate Number of Sheets button. We see that the number of sheets required is greater than the number of sheets we entered on the Select Sheets tab, so we select the Update Sheet Count button. We are informed that the sheet count has been updated, and we pick OK to close the dialog. Now we'll select Execute Nest, and we're moved automatically to the Preview Nesting tab. Here, you can preview each sheet and request a report if needed. Notice that Part 4 here was the one we fixed in its orientation, exactly as it was when it was staged. The last thing I would like to do is to impose a grain direction control on this larger part. In order to do that, I need to specify the grain direction on the stock material as well as the part. First, we'll go back to the Select Sheets tab and set the grain direction to a long X for both sheets. The system warns you that all sheets must have the same direction. Pick OK, and all sheets will be assigned the new direction. Then, on the Select Parts to Nest tab, I will set the grain direction on that part to be a long Y. Now we'll select the Choose Nesting Parameters tab, execute and preview the nest again, and we see that those parts are aligned vertical now. Let's look at the other sheets as well. Now, each time the nest is generated, the system will calculate an efficiency factor, referred to as % utilization of the stock material. Once we're satisfied with the layout of the nest, we will select the Commit Nest button. This writes the geometry of the individual sheets onto individual layers in your current CAD part file. The geometry can then be used for machining or any other application you wish. This completes the Quick Start tutorial for True Shape Nesting, brought to you by MecSoft. For further assistance, you can visit the online help supplied with the program or visit www.mecsoft.com for additional tutorials. Thank you.